show mode, sir?
Yes, we can see it.
Okay. Good afternoon, everyone. Thank you for giving me an opportunity to present in this conference. So, myself, Pramila, along with Dr. Samiksha Shukla, I would like to present the paper on an architecture for risk-based authentication in a multi-server environment. So, this main work focuses on authentication system, which is basically meant for the user to detect anomalies. And the main idea behind this is where can use adaptive authentication, which is basically an advanced security solution to detect the user behavior. The concerns here are there are a lot of work which has been proposed on detection of user anomalies using adaptive authentication, but very few work is proposed with respect to identification of user during initial few login attempts, and also a combination of an architecture which can be used where we can use machine learning technique as well as statistical based approach to detect user behavior anomalies. So for this, we have proposed an architecture to estimate the risk for the user during initial login process as well as when the user's data is extracted enough for the prediction in multi-server environment. The work which was started was initially was a work which was proposed by Dr. Mishpaudin et al., where a design of risk-based authentication system using machine learning environment was proposed using context-based information. This was specifically done using adaptive authentication system itself. Later, certain other works were proposed, which is risk-based static authentication. This was basically using context and behavioral information. Another work was proposed by Ding et al., where it is user identity authentication and identity based on multi-factor behavior features. This also was using behavioral data to identify user anomalies. Next, the work was proposed by Martin et al., where an approach to detect user behavior anomalies in identity federation. This used both context and behavioral information. And recently, the work was proposed by Whitling et al., which was an intensive work based on pump-up password security, where this is also to identify the risk-based users using machine learning technique. But the difference is here ML algorithm used to decide the threshold, not to predict the user anomaly. So, based on all this work and the gap which we have identified, a control flow architecture was designed for our work. So here, as shown here, initially we'll take the user details. So user details will be going to the user context storage, where a risk estimation is done. For risk estimation, we have risk policies through which we can decide whether the risk factor, which is calculated based on the data which we collected from the user, is acceptable. If it is acceptable, we do not take up to MSA. If it is not acceptable, then we raise an MSA. Now again, if the MSA is not cleared, we move it back to deny access or else we grant access. This is the basic authentication system which is generally there for all most of the RVSs. But what is that which we are proposing here with respect to multi-server environment is we have divided our data into two tiers here. That is an application tier and a data tier. So here, an application tier is basically where we can see is user management API. This is where our third-party application resides. Normally, a third-party application will, if they're associated with us to identify the user or authenticate the user, then we will be associated with multiple servers. There are API, that is risk estimation API will be over associated with multiple servers. And this risk estimation API, if we see, has another dedicated database, which is on the data type, which is the risk evaluation database. So if you see, user management API have their own database, but we have no connection to their database. We extract the user parameters, and those parameters are stored in our risk evaluation database. Now, this is the initial phase when the user data is not sufficiently there for an ML models to run. For a certain login attempts, we have this model running, which is risk evaluation API. When we have sufficient data which is collected from the user for our machine learning models to do the prediction, we move our control along with the risk API, we move our control to the machine learning training model, which is on the data tier again visible. So we have another set of database which is basically storing data for machine learning models to get trained. So if you see, this is RAS, risk authentication server, where exactly a model runs to authenticate the user. So this division of two tier is basically to ensure that our database for model training as well as for risk evaluation during initial few login attempts are maintained separately, such that the model training database is updated on the regular basis based on the risk evaluation data which we collect. Now, to get into implementation, whatever data we collected, we have divided into three groups. The main reason to divide into three groups because all these features are related to a particular geographical device or login behavior. So if we say geographical behavior can be geographical or network information can have latitude, longitude, location, time zone, and IP. Whereas device information, what we collected is associated with the device only. It can be browser, operating system, canvas, screen, language, system type. Login behavior is basically what time they have logged in, duration of login, start, weekend, or round trip time. So why we have divided them into three different categories is because we have users who frequently change with any of these categories. Some users keep changing their network, that it can be they may be traveling on a regular basis. So we'll be able to accommodate the threshold, separate threshold for each of these groups. Few users are there like admins who frequently change their device or browser information. So we can have a separate threshold for this, and as well as login behavior information. Normally, this division was done in our approach for the first time here. So what is our methodology here? Where UPWI is the weight factor and UPSI is the probability occurrence of the value which we calculate. So we basically check over here what is the probability of the value in the database. So if that value is beyond threshold, what we have, if the value is enough significantly less, then we keep the risk factor as 0. If it's not, then we take the risk factor as 1 because our threshold factor decides if enough of data is there in the database, we take up to be 0. If not, which means the higher risk, we take up to be 1. That's the reason we have taken E1 and E2 as the thresholds. Now, as mentioned here, conditional evaluation. What is the strategy behind our evaluation? As we have grouped these features into three different categories, our grouping will be having separate threshold for each of these categories. So we can see LOR of CG4, now CG5 and CG6, these are three different categories. Now, each of these will have different thresholds through which a user risk factor has to clear. If it is not clearing, then we will raise an MFA. And this is the threshold factor which we have chosen. That is, initially, if it is geographical and network information, then we have what is the threshold which we have taken is 0.1 to 1. Device and browser, we have taken 0.4 to 0.7. Login behavior, we have taken 0.5 to 1. And this is LLS and HLS is nothing but low-level risk, whereas high-level risk, if the threshold goes beyond 0.1 or 0.7 or 1, and high-level risk, which is nothing but the user will be raised 2 MFAs. So LLS is nothing but user will be raised with only 1 MFA. Now, the concept behind having 2 levels of authentication here, as you can see here, level 1 authentication and level 2 authentication is initially when the user is trying to access any application, we extract the user details, and initially we will have only certain set of parameters through which we are able to or identify the risk. If in case the user is not able to clear the MFA, then the user will be moved to level 2 MFA during his next trial of authentication. So that's why we have level 1 and level 2, which is basically also a new approach in our methodology which we have proposed. And use cases for threshold deciding factor, on what basis did we decide the threshold is, there are certain parameters, features I would say, which are dependent on the other features, whereas the others are not. So if you see, as the latitude changes, longitude also changes. So if the time zone changes, then location, latitude, and IP also will change. So here IP was the only one feature which basically is independent. Because of IP, some other features will not change. Whereas if you see device and browser information, if you see same screen size, just because of screen size is there, other information will not change. Whereas if you see system type, when system type changes, canvas and WebGL will change. So based on this hierarchy, we have chosen weights for the independent features as the higher one. So results of the level 1 authentication, which is shown in this table, as we can see user ID, time zone, IP address and canvas. Whenever there is a change, we calculate the risk factor, and the risk factor is calculated here. As we can see, there are 3 categories. For each of the group, the risk factors are taken, and if it goes beyond threshold, then MFA will be raised. This is for level 2 authentication, which we had calculated, where it consists of all the features. I had mentioned earlier, level 1 authentication has only certain set of features, which we have chosen based on the entropy, or certain set of features which are more important. And the other features goes for level 2 authentication with the combination of level 1 features. Now, what methodology we had proposed? We came to know that there is a problem here. That is, when we are using probabilistic approach, there is a concern as the data set size grows. When a new feature comes in, it is difficult for that particular feature to reach to a particular threshold value because of the data set size. Initially, when a new data set, a new feature comes, that particular feature to reach the threshold, when the data set size is small, may not be a problem. But as the data set size grows, there is a probability for a feature to reach the threshold value is very less. So that's the reason when we tried this on a public data set, we got to know that this problem has to be rectified. So we proposed modified that existing problem into, instead of probability solution, we took up an occurrence-based solution. So instead of, the same concept will be same, just that we will not be using probability-based approach, but occurrence-based. What is the occurrence of that particular feature in the database rather than the probability? So based on our methodology, we have calculated the risk for initially first few login attempts. As you can see, we have taken a user 1, user 2, user 3, user 4. So we have taken all these users from a public data set where you can see user 1 is basically the one which has maximum user session data, whereas user 2, 3, 4 has a lesser session data, but all of them have user detection anomaly data in it. So because of which we were able to see that FAR comparatively in our model is an average of 0.16, whereas in model 2 is 0.54. Now, when we talk about this model 1 and model 2 is a general model which were used in the existing research. That is, recently, whatever research were proposed, most of them have used all the parameters to detect the user behavior anomaly, which follows the approach of model 2, whereas we have used model 1 approach where it is first level 1 and level 2 authentication, where we can see that FAR is comparatively better in terms of model 2, which is an average value. And weightage for the features are here. That is, we have IP address, as you can see, the weightage is here. Now, how did we divide this weightages? For each group of feature, I've given a weightage of 1. That is, if we see IP, ASN, country, and region is basically one group of features, so I've given the weightage as 1. Device type, operating system, browser is another 1, and RT and login time is another 1. So basically, total weightage is 3. Now, as I had mentioned earlier, weightage is grouped in, the features are grouped such that we are able to identify the user based on the behaviors or the category which they belong to. So in level 2 also, we can see the IP and ASN, all these features have a slight different weightage because level 2 features, it's a combination of all the features. Along with this, we have, as mentioned earlier, it will be in our architecture that after certain level of data that we have accumulated, our model works with a machine learning model. So machine learning model, we have used SVM, naive Bayes, random forest, and XGBoost. So a combination of this data is what our prediction will take place. And based on the prediction, we can see that our naive Bayes, RF, and XGBoost, and SVM, we are taking a combination of data because sometimes the prediction may go wrong with one particular algorithm. And with the imbalanced data and the balanced data set, we can see that the results are quite good in with the target encoding and SMOT technique. We had to balance the data, the imbalanced data, we had to get into a level where we can use it for prediction. So we can see that SMOT target technique is comparatively better with prediction in the ML model. So with this, the conclusion states that the architecture which we proposed was mainly that when we collect the data from the user and try to use our risk estimation methodology for detecting the user anomaly, during the initial login attempts, is it possible for us to identify the user anomalies? And we have proposed that methodology. Yes, we will be able to identify the user behavior anomalies during the initial model login attempt, as well as when we have data which is collected from the user, we will be able to use machine learning techniques as well. In spite of having in the multi-server environment, we will be able to accommodate this methodology. So that's all from my end, and thank you for the opportunity for presenting here. Any questions?
Thank you.